Hello, thank you for joining us. This is a conversation with Albert Rooyakers, CTO and founder of Bedrock Automation. Welcome.
Good to be back, Mark.
So ExxonMobil has recently announced a joint effort with Lockheed Martin concerning open systems and secure systems. The term open secure automation is one that Bedrock has been using for quite some time. Can you describe what Bedrock means by that?
Well, that's a good question. It really defines who we are as a company. Bedrock's been around for 3 years, and we started with the mission to deliver open, secure automation platform. So open and secure is a bit of an oxymoron, and it's a little bit difficult to understand, but let's look at security first. A secure system, a tenet of security, is simplicity. So by simplicity, you reduce the attack surface. So one of our missions with a blank sheet of paper was, let's consolidate the silos of automation technology that have been in existence for decades. That's like PLCs and DCS, SCADA systems, safety systems, and converge it into a single architecture. And that greatly improves the security because you simplify the system. So that's a side benefit and an important directive. Now, security, to build it in versus bolt it on, which we've written about and spoken about, means you have to go deep inside the technology and you have to use secure components. And what a secure component means is that the microcontrollers and the microprocessors themselves are secure. And that's a mature technology that's available today for embedded systems. And that means you have things inside the chips like secure memory, secure processors, true random number generators, crypto engines, and other things that mean that the cybersecurity is built into the component itself. Now, on top of that, you layer a secure RTOS. And in our case, we're using Green Hills Integrity. This has partition technology in the RTOS that prevents the whole system from being knocked over so easily. Now, all of these things are really a function of authentication. Authentication is the root of security. So by having secure components, you can authenticate the component to the board, you can authenticate the board to the module, you can authenticate the firmware in the software to the processor. And then you package it into cyber hardened packaging. So you use physical, all metal sealed containers. So these are the layers of cybersecurity that's built in versus bolted on. So that's the essence of security. Now, an open system, it's a little bit easier per se than security because there's a lot of good maturing standards around open. An example is OPC UA. Now, OPC UA client server, if we deploy that in the system as we have, that means you decouple the system from the application layer and the SCADA and MES layer. So the benefit to the users are you can have best-in-breed technologies and you can mix and match rather than typical stovepipe solutions of the past. So another example is 62443 and 61508. These are two other IEC standards, one for security, ISA Secure, and the other for SIL, for safety. And they're related to each other and quite similar. So if you use those standards as guidelines, then you can build a system that has levels of security and levels of safety. 61131 is another example where this gives you the tools to allow a full and open engineering environment for a system configuration. And another example I would cite is Ethernet. So Ethernet is by far a de facto standard. Being compliant with Ethernet IP, Modbus TCP, and other IP-like standards, then it gives you all of the tools that you need to build open and secure automation. And that's what Bedrock is, and that's what we've built.
Great. So in 2015, you kind of came out of the shadows and announced what you've been doing for the last 2 years at that point. What have you been doing since?
Yeah, the last year has been one of the most exciting and most important years. When we were here last year, we were showing some of our alpha and beta products, right? But in September of last year, we went into full production. So we had only months to go from alpha and beta into full production. So we had to completely build our supply chain and our manufacturing infrastructure. And what's also unique in this case is that our manufacturing infrastructure is cyber secure, because these modules have to be built in a secure infrastructure so that keys and a device lifecycle management infrastructure had to be built too to insert these crypto keys in the modules. So all of that heavy lifting had to be done in the past several months. And so we started shipping in September. We've shipped several dozen systems to companies in various countries. And we now have a couple of systems that are live since November of last year.
Which industries have shown the most interest?
Yeah, that's a really good question. And the exciting part is that even in early adoption, we see a broad base of use. So we have discrete parts manufacturing, we have factory automation, we have chemical and hydrocarbon processing, and we have utilities, water and wastewater. So it lends itself to the idea that you really can unify automation into a single architecture, and you can do the things that are typical of these silos of automation, and now we can do it with a single platform.
Okay, so based on your accomplishments last year, what are your key initiatives for 2016?
Yeah, so when we're talking about security, all the pieces, and there's so much more to it than that, is we build something that we call the hardware root of trust. So it's like when you're online banking and you trust that you'll be able to do financial transactions because VeriSign is the root of trust between you and the bank. Well, by deploying these technologies that we've talked about, then the control system becomes the hardware root of trust. So now we can use that hardware root of trust to extend security in a number of directions at the same time. One is we can push down to the edge devices and truly deploy secure Internet of Things. So we can use the system to authenticate the edge devices and use the system to create a secure tunnel and a secure socket to the edge devices. So that's one direction. The other one is to be able to use that same root of trust upward into the communication layer and the application layer that's typical of systems. So these are the things we're working on this year. We're very, very excited about it. We'll see some hardware, software, and firmware releases. And this will really show the world that we can build holistic cybersecurity that's simple and integrated into the system.
Okay, so in the North American market, most of the projects are brownfield, right? You've got an existing system. What is Bedrock, or is Bedrock being considered for some of these projects, and what can you tell me about them?
Yeah, so there's differences, of course, as we all know, between a brownfield automation project and a greenfield. And so the benefits that we have for brownfield automation are some really important ones. One is you want to be able to insert an upgraded system anywhere, or you want to have the flexibility within the signal path, so that you have complicated wiring systems and so on. You want the system to be modular, small modular footprint that can be distributed, highly distributed, which is what we've done for both the control and the I/O. And the other one is you want hardening, so you want it to be very harsh, and you want flexibility in the system. So by having soft configurable functionality, soft configurable I/O, you install the technology and the system can be more flexible to what the actual existing infrastructure is. And then, of course, security is going to be important in brownfield or greenfield, because brownfield automation, you want another 20, 30, 40 years of life in the system. And so security has become a dominant theme, and it will become more so in the future. So in a brownfield automation, you know that you're installing a system that's relevant and will have the security and the features that's required for the next several decades.
Great. So you just announced, Bedrock just announced a new UPS product.
Yes.
What differentiates that in the market?
Yeah, that's, again, we're very, very excited about that, because the UPS is the complement to the other power product we announced, which is our power supply, the SPS. So those two pieces are all of what we think is the solution, our simplified solution for power. Now, the UPS deploys all of the best technologies, and starting from the lithium polymer cell technology that's inside of it. This gives us about an order of magnitude improvement in energy density and reduction in footprint. And then, of course, it has all of the cyber capabilities, has hardware and software authentication. It's in a sealed, hardened box, both of them are, so they can go out into the field in NEMA 4X, IP67 rated environments. So it's highly distributed. Now, there's a trend overall in industry to decentralize power. Want to chop it up into smaller pieces, get it distributed, make it smart, and allow the system to communicate to it. Well, that's exactly how it's been architected. So it's a complementary product to the power. It has crypto and communication technology built in. So it can communicate with any legacy system on any standard Ethernet network. It can communicate more tightly coupled to our automation system, or it can just exist as a passive device as standard power supplies and UPSs are today. So it fits anywhere.
Great. Thank you very much.
Thank you.
This has been a conversation with Albert Rooyakers, CTO and founder of Bedrock Automation. Thanks.